Hi guys, thank you for watching my previous videos. I hope you have enjoyed them. So today we are looking at a new chapter, Properties of Circle. So now we are at the second slide. So we have some rules for this chapter, Properties of Circle. So let's take a look at the first rule. This rule is called angle in a semicircle. So I hope you know what is a semicircle. A semicircle is half of a circle. So let's take a look how it looks like. So here we have a diameter of this circle. So I'm drawing this on the diagram. So if you are to form a triangle within this semicircle, and you should form a right angle triangle. And you can see I'm forming another right angle triangle within this semicircle. Sorry, let me draw it properly. It does not look nice. So with this diameter, if we are to form another triangle inside this semicircle, we should form another right angle triangle. And the same thing applies to the third triangle here. So you can see we have three right angle triangles in this semicircle. Therefore, this rule is called angle in a semicircle. Okay, right now, let's take a look at another rule on this slide. It's called angle at the center equals to 2 times the angle at the circumference. So you should be able to see that within this circle, we have a center and we have an angle at the circumference. The angle at circumference is A, therefore, because of this rule, the angle at the center is 2A. So let's take a look at the third rule on this slide. So over here, you can observe that we have angle A, and we have another angle, and these angles are the same, and this rule is called angle in the same segment. Now let's come to the fourth rule on this slide, and I have circled angle A and angle C. So the summation of these two angles should be equal to 180 degrees. So the rule here is called angle at opposite segments. If you are to use these rules, please state it at the end of your answer. You have to state it. So over here we have 4 rules. Number 1, 2, 3, and 4. And I hope it looks easy to you. And on the next slide, we will see some application of these rules. So over here, we have a question. So in this question, we are to ask to find the radius of the circle, which is OA. Or you can simply find OE. So what we have here, so we are told that AB equals 26 cm, and D is the bisector of AB, and we have CE as the diameter with O at the center. So we can actually find OA. So let's let OA equals to RCM. So let's do for AD. So as D is the bisector of AB, therefore AD equals to half AB, which is half times 26 equals to 13 cm. So we have AD equals to 13 cm. So therefore, we can extract out this triangle, which is a right angle triangle, OAD. So OAD, angle OAD is theta, and OA is the radius, we let it be R, and AD is 13. So how do we find OD? If we can find OD, we can find R. And by the way, over here, OD is 13 minus DE. No, it's not. So let's take a look at OD. And I'm drawing in the diagram. So I have OE. OE is the radius, and D is in between OE. And we know that DE is 8 cm, given by the question. Therefore, OD equals to R minus 8. So therefore, we have our OD found. So let me remove this 13 minus DE. So what we have, OD is actually equal to R minus 8. So with OAD as a right angle triangle, we can use Pythagoras theorem. So C square equals to A square plus B square. So over here is R square equals to R minus 8 bracket square plus 13 square. So let's expand it out. And simplify it further. So please take out your calculator. And I will move the R one side and the non-R one side, and therefore your R should be equal to 233 over 16, which is equal to 14.6 cm, by the way, to 3 significant figures. Remember to add the unit. So I have forgotten to add the unit here, so please add it yourself. So we have found the radius of the circle. So now we are asked to express angle ACB in terms of theta. So angle ACB is actually the angle at the circumference. Therefore, if we can find the angle at the center, then we can find the angle at the circumference. So therefore, let's extract triangle OAB as follows. And we are given OAD equals to theta. Therefore, angle OBA is also theta, base angle of a isosceles triangle. So with angle OAD and angle OBD found, therefore we can find angle AOB. So angle AOB equals to 180 degree minus 2 theta. So therefore we can find the angle ACB, which is the angle at the circumference. So remember the second rule on the first slide. What it says angle at the center is 2 times the angle at the circumference. Therefore, angle ACB here is half of angle AOB. Because of the rule, angle at the center equals to 2 times angle at the circumference. So you have to write this rule down. Otherwise, you will be penalized. Therefore, half of angle AOB is 90 degree minus theta. So we have answered this question. Now let's take a look at another question. So over here we have a diagram. AC is the diameter. Therefore, angle ABC is a 90 degree angle. Why? Because we can use angle in a semicircle. And we have OD is parallel to AE. and we can actually find angle AOD equals to 138 degree, because we can just take 180 minus 42. And we have angle EAO equals to 42 degree as well, corresponding angle. So we are asked to find OCD. So remember, OD equals to OC, they are both radius. So therefore, angle OCD equals to, or angle OCD plus angle ODC equals to 180 minus 42. So what is the rule we use here? Angle sum of triangle. Therefore, angle OCD plus angle ODC equals to 138 degree. Because angle OCD equals to angle ODC, therefore, we can use 138 divided by 2, we get 69 degree. So over here, we use base angle of an isosceles triangle. Please add in the statements. Over here, I have not added in the statement, but you have to do that, otherwise you get penalized. So I will label the angle accordingly in the diagram. So let's move on. Let's find out what is angle AED. And I hope you observe that AEDC form a four-sided polygon in the circle. So let me extract that out so that you can see it clearly. So over here we can make use of what rule? We can make use of angle at the opposite segment. Therefore, angle AED plus angle A all, let me undo it. So we make use of the rule angle at opposite segment. So 180 degree equals to angle AED plus angle OCD we found for part A. Therefore, angle AED equals to 180 degree minus 69 degree. Therefore, we get 111 degree. So over here, we use angle at opposite segments. So please write down the statement once again. I have to remind you. So now we can continue to find part C. So part C, we are asked to find angle CBD. So CBD is labeled in the diagram. So over here, which rule we can use? Can we use angle at the same segment? No, we can't, because this arrangement is different. So what can we use? So for angle CBD, you should be able to observe that this is an angle at the circumference. So we can make use of angle at the circumference times 2 equals to angle at the center, right? Therefore, we can use this rule to find out what is angle CBD. So angle CBD is actually equals to half of angle COD, right? So therefore, it's easy now. Angle CBD is equals to half of angle COD. Which rule we use? Angle at center is 2 times the angle at the circumference. Therefore, angle CBD is actually equals to half of 42 degree, which is 21 degree. So you can see me write it out, and we get angle CBD equals to 21 degrees. So please write down the rule you use, otherwise you will get penalized. So the rule here is angle at center equals to 2 times angle at circumference. So now let's take a look at part D. So part D, we are asked to find OAE. OAE, okay, we have found it just now. So angle OAE equals to 42 degrees. Because OD is parallel to AE, therefore we can use the rule of corresponding angle. Now we have come to the final part, part E, angle ABD. So angle ABD is equals to angle ABC minus of angle CBD. So therefore, angle ABD equals to 90 degrees minus of 21 degrees. So angle ABC is 90 degrees, angle in a semicircle. So angle ABD equals 90 minus 21, we get 69 degrees. So, hey, now we have come to the last question of this chapter. So I hope you can follow closely by now. So let's take a look at this question. So we have angle ACB found, which is 90 degrees, angle in a semicircle. And we are told that BC equals to 5, CT equals to 4, and we are asked to find angle ABT in terms of theta. So AB is our diameter, by the way. So how are we going to do this question? So let's do it. Part A, angle BAT. So angle BAT is 90 degrees. Why? Because it's tangent to the radius. So we have found angle BAT equals to 90 degrees. So please write down the rule you use here. Radius is perpendicular to the tangent. So OA is our radius. And AT is our tangent. Therefore, we get angle BAT equals 90 degrees. The rule is radius is perpendicular to tangent. Therefore, angle BAC equals to 90 degrees minus theta. Right? So with that found, our angle ABT equals to, or our angle ABT plus our angle BAC equals to 180 minus 90 degrees. Angle sum of triangle. The triangle we are talking about is triangle ABC. Therefore, let's sub in what is found. So angle ABT, which we need to find, plus our angle BAC we found above, which is 90 minus theta equals to 90. So angle ABT equals to theta. So we have found angle ABT already. So now let's go on to show that triangle ACT is similar to triangle BAT. So how to show one triangle is similar to the other? So let's extract these two triangles out. So let me extract these two triangles out first. So let's first extract triangle CAT. let me draw it nicely. So we have triangle CAT drawn. It's still not nice enough. Let me try again. So let's draw out triangle CAT. Okay, so this one looks better. And please allow me to label whatever is given in this diagram. So I have labeled them: angle theta and CT equals to 4 cm, and angle ACT equals to 90 degrees. So let me extract the other triangle out, which is BAT. So give me some time to draw it out. And we know that BAT is 90 degrees as well, and ABT is theta, which we found just now. And we have BT equals to 9. Okay, so we can use AAA to show that these two triangles are similar. So we have common angle, angle CAT equals to angle ABT, which is equals to theta, and angle BAT equals to angle ACT, which is 90 degrees, and angle ATC equals to angle BTA, which is common. Therefore, with AAA, angle, 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 so we can prove that triangle ACT is similar to triangle BAT. So now we have come to the last part of this question. We are asked to find the length of the tangent AT. So we have BT equals to 9. So by using similar triangle property, so we can form an equation. AT, if we let AT equals to R, so you can see I label R on the diagram. Therefore, once again, using similar triangle property, so we have R or AT over BT equals to CT over RT. Therefore, we have cross multiply, we have AT squared equals to BT times CT. So BT equals to 9, CT equals to 4, therefore AT squared equals to 36. And AT equals to 6 or minus 6. But we have to reject the minus sign, minus 6, because the length is only positive. So please add in the unit there. And we have come to the end of this chapter. Hope you have enjoyed it. Bye.